Welcome to the third and the final part of the series on prototype to production on crafting your applications on Azure Cosmos DB. I'm Saranya Sriram, Principal PM on the Cosmos DB team, and I do have my colleague Sandeep here with me as well.
Hi, everyone.
So as a quick recap, moving on to the next slide, we did have part 1 and part 2. Definitely request you to watch these videos as prereqs. The part 1 dealt about the overall scenario, a scenario wherein the application is working well in dev test, and the app that you see here, the snapshot of the app, is a chat application, an AI-enabled chat app, where when you move from dev test to production for various reasons, there used to be performance issues, sometimes availability issues, etc. So we were just trying to simulate a real world example and trying to troubleshoot issues. In the very first session, we looked at the first issue, which is to identify why could there be lapses in performance and higher latency, and understand what it is to truly partition data model in terms of a distributed NoSQL, DSQL data store as Cosmos DB. We also took a look at certain helper tools. Of course, there is Azure Cosmos DB metrics and log analytics, but in this case, Sandeep built in using SDK diagnostics and built up a small application wherein you could actually get the diagnostics for every request instantaneously for us to be able to observe results. So that was the first session. Moving on, the second session, which is also a prereq, is to identify certain other scenarios. So one issue that we did talk is the application being crashed whenever the volume was very high. And then what is the right SDK access patterns, best practices on SDK access, along with the key focus on singleton pattern, the client to be a singleton client to access so as to not create multiple threads and then they are competing and crashing on high volume. The issue number 3 was specifically on, hey, I'm trying to take this a single tenanted app to become a multi-tenant app. And that means I'm having multiple bulk ingestion coming from various tenants. The minute there is bulk ingestion, the actual application not performing well, while also the bulk updates are also not performing enough as well. So we did take a look at the Spark SDK from our side, and also concepts around priority-based throttling, where you could set up high priority and low priority, the background jobs, in this case being the bulk upload. So those were the couple of scenarios that we looked at. Now coming over to our third and final part, we'll be taking a look at some best practices as opposed to direct issues or performance issues, right? So in this case, the customer specifically is asking us about high availability options, guidance, right? So they've told us that, hey, we've enabled continuous backup. We also want to make our service availability not impacted during regional failures. So help us on creating a very robust high availability setup for us. And really the differences between HA and given that we already have backup, things like that. So Sandeep, do you want to take us over?
Sure. So when we talk about high availability in Cosmos DB, backup is not the right tool for doing that. Multiple regions is the right tool. The reason why we don't talk about backup being the right tool is because when a region is down, the service itself is down, you cannot take your backup and restore and create your service at that point. So it's not going to work as your disaster recovery or a high availability solution. What you really want is that use the Cosmos DB multi-region capability and say, okay, if one region is down, let me use the other region and use that region as to support my request while the primary region is down, right? So also Cosmos DB comes with this concept of, when you say multi-region, we have this multi-region as read-write regions and write-write regions or multi-master regions, right? So my suggestion that we talk about whenever we talk about high availability is customers should have at least 2 regions. possibly right regions. That gives you the highest level of availability in case of regional failures happening. Now, of course, we in that configuration, every region is writable. You write to the closest region that you are. We also have the zonal availability concepts that are there. So even if in a given region, we can have zonal availability configured so that the outages can be further localized. And if one small data center is having a problem, then the other data center, which is the other availability zone, that supports you. So use these constructs to improve your high availability rather than using backup. Backup you will use to restore some lost data, some accidental delete, some accidental update. So use backup for that purpose, but for any high availability, use zonal availability, regional availability as your basic tools.
Great. Do you want to show us in action in terms of some simulations of how it is so easy in Cosmos DB to be able to hit one region versus another region?
Yeah, why not? So let me switch and take you through sample app that we have and see how that works. Again, going back to our application, we have your helper tool on the left, our application running on the right. And what I'm going to do now is just if I click on any item here, just like we did last time, I'm supposed to see the request showing up here and it comes. But this time I'm not going to focus on the top two charts, which is what we were focusing in the previous sessions. I want you to focus on the third chart at the bottom. So let's look at where this request is coming from. You're seeing that you're getting a 200, which basically means it's a OK. And it's coming from Central India. Now I am recording from India and my database account is in two regions. I have added it to Central India and West US. And since I'm closest to Central India, my request is being responded from Central India region. Now, this is good scenario, right? I'm happy, everything is good. But what if Central India is down for some? Let's assume that. And to mimic that, what I did is I created a small application here. And what it is going to do, it's basically going to mimic as if Central India is down by using a firewall tool. Basically, what I'm going to do is once I enable this, it's going to create a firewall rule on my local machine, and it's going to block my requests that are going to Central India. Now, as far as the SDK is concerned, it doesn't know that. So it is going to behave as if Central India is not reachable. So now if I click on the same chart, let's see what the response comes. Oh, see the response now came from West US3. So the request first went into Central India. It was not served from there. So the SDK went to West US3 and said, get me the data. So as a customer application, let's just pause this and just want to spend some time here. As a customer application, just because Central India was down, you didn't have to do anything. The customer app just worked well. But here, if you see, there is a small difference. The latency has gone up. Something that was taking 200 milliseconds now took 1800 milliseconds. Now, why did that happen? Because I selected some regions which are completely geographically as distant as possible. So I selected Central India and West US3. If my second region was, let's say, Southeast Asia or South India or something which is close to Central India, then this problem would not also have happened. My latency would also have been down, right? Now, how many regions you want to select, which are the regions that you should have. Those are, of course, your choice, your workload. So in my case, I created two regions because let's say I want to serve customers in the Asia Pacific region from South India, Central India, and my customers in the Americas from my West US3 region. But if my application primary users are in this region, then I should not have used West US3. I should have used a region which is both close to me, right? So that is the now question here is, okay, this all sounds very nice. What is the code or how much code do I need to write for this? So let's dive into the code and see what has to be done.
Sandeep, just to also highlight this latency is end-to-end latency, right? We are talking about.
Yes, of course. Yeah, I think we said that last time. So this latency is end-to-end latency, and that is why it is high because the request is actually going from my desktop, which is sitting in India, going all the way to US and coming back. So that it is taking time traveling across the seas and coming back. Yeah, so it's
can't beat the laws of physics, can we?
Absolutely, absolutely. So let's come to the application and see what happened. So here in my application code, you see that I have application preferred region given here, and I given my preference. So you could give your preference. So you add your own regions in the account, and you give the regions here. So if I go to my Cosmos DB service, you can see that when I create my client options, there is an option called application preferred regions, and I give it a comma separated list of my regions here. So I just take that application setting, I split it into an array, and I provide it to here, and that's all. Once you provide this setting to the SDK is smart enough, and it will automatically figure out what to do when a region is down, and it will automatically switch over. So as a summary for what the customer should do, my simple solution is go to your Cosmos DB service on your portal, add multiple regions. If possible, create them as multi-write regions, and then set your application preferred region here. And then the system should automatically take care of anything that's down, and you will get the highest SLA.
Awesome. Yeah. So maybe we can just go over a quick best practice recap of what we just saw now. It's an awesome demo actually, wherein we do recommend you to have more than one region. If you have the right consistency constructs to make it multi-write region, great. But otherwise, at least single write but multiple read regions. And the minute we do have that scenario, then essentially what you want to do is to have a good failover mechanism. One option you do have is something called service managed failover, or there is a manual failover. We'd always recommend you to enable service managed failover. Whenever there is a service discrepancy, you will have a failover automatically done. However, manual failover is situations where you click on that button, manually failover to a region, then it goes to another region. However, the manual failover happens only if both the regions are completely in sync and there is no data discrepancies or data losses. So during situations of service outages or when service managed failover, if you do try to speed it up and click on a manual failover, then essentially you will get stuck or be in a limbo because the systems will, or the two regions might not be in exact sync because there was a region outage. So something to keep in mind when you do multi-region accounts. The other piece of this, Sandeep, you mentioned very vividly on the code as well, is to set up your application preferred regions. It's mandatory to do this. I think it's just best practices. Depending on where your app servers are, as Sandeep said, if you had two application servers, one in India and one in the US, each of those application servers app preferred regions would have a different order, each one going to their respective database regions closer to them, right? So that's that. Also, I'll just probably highlight one aspect that just because you're adding another region, your costs will not be increased. We are rolling out what is called as dynamic scaling on auto-scaled accounts. We request all customers to move to auto-scale because auto-scale itself comes with extremely balanced pricing as we speak, where you are exactly charged at a partition level to what you're using. So if you do have another region and that region doesn't get enough requests, then you will not be charged for the region as much as you're charged for your primary region. So in all, it's a good thing to have multiple regions here.
Yeah.
Right. So let's go to the final piece of this webcast in terms of having another guidance on creating a good RAG pattern. All this while, we did talk about an AI-enabled application. It was very cool, but we really didn't explore ways to utilize or make that real. So in this scenario, for example, if we go ahead, we do want to add specialized data. So the data which is going to be ingested and this data being used for in the RAG pattern for our searches. So Sandeep, do you probably want to give us an idea about the problem that we are solving here?
Sure. So the problem statement is basically the customer in this case wants to figure out a mechanism of adding more technical content. So in this case, as you know, Contesto Systems is creating a chat application to support technical questions that come from the customers. And RAG pattern basically is used to provide your knowledge base so that the AI bot can start using that to respond to the customer queries. Now, one of the primary requirements for that is to be able to give your knowledge base in a form or shape that the AI bot can use. And that's where we use the RAG pattern, right? And as part of the RAG pattern, one of the requirements is to create embeddings and do vector search, etc. So the challenge here the customer is asking is, okay, today, let's say we have vectorized all our technical guides and the data is ready. But guides will keep getting updated. New guides will be created as technology evolves, things will change. What is a good mechanism by which they could, update or add new guides to the system in an automated manner, right? So for doing that, my suggestion here is to use the change feed that Cosmos DB comes with. And maybe I can just talk about what Cosmos change feed is and how it works. So let's look at this picture here. And let's say there are these different containers that are there in Cosmos DB. What Cosmos DB does is whenever you do any kind of update operation on the container, it maintains a feed of all the changes that happen. That's called the change feed. And think of it more like a log of each update that happened on that container. Now, this log can be read using what we call a change feed processor. And you could have multiple change feed processors for a container also and that way you can, for example, if your number of changes that happen to your container are very large, then you can have multiple change feed processors for the same container also. But for simplicity, let's assume that there is one feed processor for one container here. And what I could do is whenever a data comes in, I could take that data feed, and then let's say in this case, I want to generate a vector here using OpenAI, and then I can store it in my vector database. Earlier, we had to use AI search as a tool to do it. Yesterday in build, we released our vector search capabilities. So now you don't have to use AI search. You can actually store your vectors in Cosmos DB and do the vector search in Cosmos DB NoSQL API itself. So that's a change. When I created this demo at that point, we didn't have that feature ready. So that's a change that happened yesterday. Similarly, you could have used the change feed to do some aggregation or some creating materialized view or things of that kind. Another use case for using the change feed is to, let's say, send emails or send SMS or do any kind of notification so that you can inform the customers of some change that has happened and then some critical action that they need to take on, right? So the change feed can be utilized in many forms. And so question is, how do we use it? So here I have shown you a sample code of how a change feed processor can be configured. So here I'm looking at a list of change feed containers for which I want to configure change feed processor. So I take that list from my config file and then I loop through that list and basically I create a new processor. I provide it with some attributes, for example, a name, etc. And then say change feed processor dot start async. Now, one thing to note here is this line, this line which is called with start time. This change feed processor can actually start from different points in time. So I could say, okay, in this case, I'm saying min value, which basically means it will read feeds from the starting of when the container got created. Or I can give current time. So from the time this processor gets initiated, it will start. So you could run it in different modes also, right? And if you create multiple change feed processors for the same container, these processors will automatically distribute the load, and you don't have to manage about which feed processor will take how much. It will automatically make sure that it gets distributed. The only limit here is that the number of change feed processors should be not more than the number of physical partitions that you have, because at the max, one physical partition, one change feed processor. You cannot have more than that, right? So once you write this processor, then you create this event here, this async task, and that's what gets called whenever a change feed happens. And you get the change event, a changed document here for example, in this for loop, and then you can do whatever you want to do with that item. You can do aggregation, you can do, like, for example, I'm doing vectorization, etc. And maybe I can give you a small demo of how this works in action, right? So let me again go back to code. What I'm going to do now is I'm going to bring up my application. I'm going to go to, so this is the start change processor code that I talked about, and this is the actual processor. Sorry, here, this is my processor here. So let me put a breakpoint here, and what I'm going to do is now I'm going to go to the portal and I'm going to make a change in one of the documents. So here I am in my document explorer, and I have my collection, a container called guides. This is the knowledge base that I'm using for serving the bot for RAG pattern. And let's say for in this sentence, I am not happy with the full stop here. I want to put up, let's say, a comma here or something like that. I just make a small change and I click on update. And let's see what happens to my code. I'm expecting that my change feed, oh, it's already here. So if you see, I can see my change feed processor got triggered, and the item that I just changed is already being reported. So I can see that the new document or the updated document is available to me. In this case, I am taking this document and no, I am vectorizing it and then adding it to cognitive search or AI search as it used to be, and then using it for RAG pattern. But what you do with this item is your choice. For RAG pattern, yes, you have to vectorize it and update it. For your own custom logic, for example, here you could do whatever you want to do to take care of it in your based on your requirement. So change feed is a very powerful tool. If used rightly, it can save you a lot of RUs, and you don't have to write your own custom code to track changes that are happening as the system does it for you.
Awesome. Yeah, I think change feed is a very, very useful feature for all applications and developers to use. They probably find some usage on change feed going forward as well. Just to say that at this point, the change feed that you see doesn't track updates and deletes. So that's something that we'll be announcing in the coming months. So if you do want to use scenarios where you're deleting and you want to check which are deleted, might not be the best use case at this point of time.
There is a way to do that also. You could actually use TTL as a mechanism to bypass that. So what you could do is instead of you physically deleting a record, you could just do a TTL. You could do a TTL of, let's say, 5 seconds or 2 seconds. Thereby what happens is, because when you do a TTL, it's just an update, a change feed gets triggered and the document will get deleted later on. So you can kind of bypass the delete limitation using a TTL by using TTL.
So what you're telling us, Sandeep, is TTL is more like a soft delete for the SDK, but at the back end, it actually triggers change feed to actually purge the document out.
Yeah, so when you do a TTL, you are updating a field because of which the change feed will get triggered, and then eventually your document will get deleted through the TTL, but that way you can also track it in the change feed.
It's a cool hack, yeah.
Yeah.
All right, so with that, we come to the end of today's session. Let's do a quick recap of summary that is across all the three sessions as such. Primary feedback based on prototype to production is to understand whether we have the right data model, we have the right partitioning strategies, SDK usage, demos that you guys saw on singleton approach, monitoring, diagnostics, metrics. Today's session specifically on high availability, multi-regions, and change feed, all of them are talking of goodness on Cosmos DB. We also have things around getting started on how to get started on Cosmos DB for free. We have a free tier and a free trial, essentially giving you quite a bit of RUs free for at least a year in terms of your free trial, and free tier is free forever. Specifically for those of you who are building AI-enabled application, there is a limited time Azure AI Advantage offer, and we will put all of these on the comments to this video as well. One thing that we didn't quite chat in today, but for completeness that I do want to bring up, is Cosmos DB has other data structures or other API models as well. The prominent ones being Mongo, both core-based or just RU API based. So Mongo API and Mongo RU, two flavors of the MongoWire protocol that we have. Similarly, we have Cassandra managed instance. Outside of that, we do have Gremlin and Postgres API via Compat as well. Sandeep, do you want to take us through migration best practices, since it's also very, very critical component when we talk of either building new applications on Cosmos DB or migrating existing applications on Cosmos DB or migrating from one Cosmos DB to another Cosmos DB as well?
Yeah, migration is a critical piece, and there are many tools that we have for supporting migration. And again, these tools are different tools fit for different use cases. For example, I already showed you one of those tools during my demo, which was the change partition key, which is internally the data transfer service, which actually is moving data from one container to another container. And while doing that, it's changing the partition key. We have online versions of it and offline versions of it. Then change PK we talked about. For Mongo specifically, we again have multiple toolings. We have the ADS-based extension that does the migration. We support native tools, which is like Mongo dump, Mongo export. And then we also have a Spark-based tooling that we use for big migrations. So if there are some requirements, you can reach out to us and we can help you onboard on that tool. We talked about how Spark is a better fit in the migration space rather than creating your own applications. Try to use Spark as a tool for migration, and there are sample codes, sample libraries that we have provided in our SDKs, etc., on how you can use Spark for the various, depending on the different APIs. And then we have this free ingestion offer where we will give you free, but they will not charge you for the migration while the migration is going on. So you don't have to worry about the cost of your Azure or the Cosmos DB resources while ingestion is going on. So we make it free for you. Yeah, so I think anything on migration, please reach out. We will try to fit you into one of the best tools that are available and make sure that your migration is a success.
Yeah, Sandeep, you are the PM point of contact for all migrations for Cosmos DB as well. So thank you on that. So we come to the end of today's session. Please do put us your comments, feedback, and you can reach us as well via these comments. Thank you very much.
Thank you. Bye-bye.